discovering an intermediate black hole, NGC 6099 HLX-1. Scientists have uncovered an extraordinary discovery, an exceptionally rare type of black hole, actively devouring a star, as NASA's Hubble Space Telescope and Chandra X-ray Observatory observe a unique celestial phenomenon. While these two space observatories may be considered relatively old, they continue to push the boundaries of cosmology. This event, known as NGC 6099 HLX-1, represents a crucial new insight into how cosmic structures evolve. As the universe expands, supermassive black holes dominate, but smaller ones, like intermediate mass black holes, IMBHs, remain enigmatic. Rogue black hole disrupting star in distant galaxy. What's going on? In a surprising twist in the cosmos, scientists have discovered a rogue black hole with a middle mass wreaking havoc on a nearby star within a distant galaxy. This fascinating observation was made possible through the collaborative efforts of the Hubble Space Telescope and the Chandra X-ray Observatory. However, the exact nature of the black hole's interaction with the star remains a topic of debate due to conflicting X-ray measurements. Black holes come in various sizes, ranging from stellar mass black holes formed from supernova explosions to supermassive black holes lurking at the centers of galaxies. In between these two extremes are intermediate mass black holes, IMBHs, which have masses between hundreds and up to 100,000 times that of our Sun. These IMBHs are crucial for understanding the evolution of black holes, but are notoriously difficult to detect due to their relatively low activity compared to their supermassive counterparts. Occasionally, an IMBH will become active and initiate a tidal disruption event, where it tears apart a star or gas cloud that comes too close, resulting in bursts of X-rays. In 2009, Chandra detected unusual X-rays from a region 40,000 light-years from the center of a giant elliptical galaxy called NGC 6099, located 453 million light-years away. This source, named HLX-1, exhibited X-ray emissions consistent with a tidal disruption event. However, subsequent observations have added complexity to the story. The X-ray emissions from HLX-1 peaked in 2012, according to the European Space Agency's XMM Newton telescope, but significantly decreased by 2023. Meanwhile, the Canada-France-Hawaii telescope and Hubble identified an optical counterpart to the X-ray emissions. There are two leading theories to explain these observations. The first suggests that HLX-1 was once at the core of a dwarf galaxy that was gradually stripped apart by the gravitational forces of NGC 6099, leaving behind a free-floating black hole with a small cluster of stars. This cluster could serve as a food source for the black hole, leading to periodic tidal disruption events. The alternative theory posits that the star involved in the tidal disruption event was not completely destroyed, but instead survived on an elliptical orbit around the black hole. In this scenario, the observed X-ray emissions could be the result of the star passing close to the black hole at different points in its orbit. To determine the correct explanation, further monitoring of HLX-1 is necessary. Understanding the behavior of IMBHs, like HLX-1, is crucial for shedding light on their role in the broader black hole ecosystem and the formation of supermassive black holes. While current telescopes like Chandra, XMM Newton, and Hubble have limited field of view, upcoming observatories like the Rubin Observatory will significantly enhance our ability to detect and study tidal disruption events, potentially revealing more about these enigmatic intermediate mass black holes. The findings of this study were published on April 11th in the Astrophysical Journal, marking a significant step forward in our understanding of these elusive cosmic phenomena. Astronomers discover rare black hole devouring a star. Stop and imagine. A ravenous cosmic monster has just been caught red-handed nibbling on a nearby star, and it may solve one of astronomy's longest-standing mysteries. Astronomers combing through data from NASA's Hubble Space Telescope and the Chandra X-ray Observatory have stumbled upon NGC 6099 HLX-1, an object sitting roughly 40,000 light-years from the center of a giant elliptical galaxy, about 450 million light-years away in the constellation Hercules. The eye-catching part? Everything points to this being a long, elusive intermediate mass black hole, or IMBH, caught mid-meal. But here's where it gets controversial. For decades, scientists assumed black holes came in only two sizes. Stellar mass black holes, born when a massive star dies, usually tip the scales at less than 100 solar masses. Supermassive black holes, millions to billions of times heavier, rule the hearts of galaxies. That left an awkward gap no one could fill. Intermediate mass black holes are supposed to bridge it, yet they almost never show up in our telescopes. They're too hefty to arise from a single star's death throes, yet too puny to shine as brilliantly as their supermassive cousins. Yi-Chi Cheng of National Tsinghua University says, X-ray sources with such extreme luminosity are rare outside galaxy centers and can serve as a key probe for identifying elusive IMBHs. They represent a crucial missing link in black hole evolution. Caught in the act. The first hint of something odd appeared back in 2009, when Chandra spotted a bright off-center X-ray source. 3 years later, the object blazed 100 times brighter, then slowly faded until 2023. That roller coaster pattern shouts tidal disruption event, astronomy speak for a star being shredded by a black hole's gravity. As the star's gas swirls inward, it feeds to millions of degrees and pours out X-rays. HLX-1's glow matches a sizzling 3 million degree inferno. Hubble piled on even more evidence by revealing a tight star cluster engulfing the black hole. The stars are so densely packed that they're only a few light months, about 500 billion miles apart, providing an all-you-can-eat buffet. Roberto Soria of Italy's National Institute for Astrophysics sums it up. In 2009, HLX-1 was fairly bright. Then in 2012, it was 100 times brighter, and now it's fading. We have to watch and see whether it will flare again or sink into silence. Why we care? IMBHs may be the building blocks of the universe's giants. One leading idea suggests that small IMBHs merge repeatedly, ultimately giving birth to the supermassive black holes anchoring most galaxies. Another claims they collapse directly from gigantic clouds of primordial gas soon after the Big Bang. If the HLX-1 is real, it proves that galaxies can host satellite black holes wandering far from their bustling centers. And this is the part most people miss. A single discovery like HLX-1 opens the door to a cosmic census. If astronomers can spot more wandering IMBHs, perhaps by catching future tidal disruption flares, they can finally estimate how many are out there and how often they snack on stars. That, in turn, tells us how galaxies grow, by gobbling up smaller galaxies, by nurturing hidden IMBHs, or by some mix of the two. Potential flashpoints? Some researchers argue that HLX-1 could still be an unusual stellar mass black hole, or a faint supermassive one masquerading as an intermediate. Do you buy the IMBH interpretation? Others question whether tidal disruption alone explains the brightness changes. Could an exotic accretion process be at work? Your turn. Does HLX-1 finally bridge the black hole size gap, or is the community jumping the gun? Should we expect countless more hidden black holes waiting for their next stellar snack? Sound off. Agree, disagree, or propose your own theory.